Welcome. Good morning. This is the talk on w3af. I'm going to be delivering 2 talks on the framework. This is the first one. Sorry. This is the first one, and the first one is just an introduction. It's going to be for the guys that do not know what w3af is and are interested in knowing. The second one is a new presentation which I haven't delivered in any other conference. It's about the graphical user interface features of the framework. And on the second session, I'm also going to be comparing AppScan, Acunetics, Sensic, and w3af, just to see how they work. Okay, so let's get started. First of all, a little bit of me. My name is Andrés Riancho. I'm from Buenos Aires. And I'm a web application security enthusiast. I've been working with web application security like for 3 or 4 years at least. And I've been writing this tool since 2007. Basically, I do web application penetration testing for a living. That's what I do every day. And I get to analyze something like 2 or 3 web applications a month. So that's why I started this project. I'm a developer. I code in Python. And I'm an open source evangelist. I use open source. I try to promote open source. And, well, in this case, I'm not using open source. This is OpenOffice, but this is Office, Microsoft Office, but it's okay. I have some knowledge on web application, on IPS design and evasion. I was playing with some tipping point IPSs, like 2 years ago, and I got lucky, found some vulnerabilities, and it was good. I'm the w3af project leader, and I'm the founder of Bonsai Information Security, which is my company, my little baby that's growing. So, raise your hands. Who works in web application security? Okay, nice. Who heard about this project before? Okay, it's a good number. I remember when I was like 2 years ago in Kansas West, and there was a room like the other one, the big one, and I asked the same question, who heard about w3af, and only 1 hand raised. It was pretty disappointing. But now there is more knowledge about it. We are in our 3rd year of life, so people are starting to use it. Who really used the tool? So, 1 guy there, 2, okay, right. And anyone tried I think you guys tried to read w3af's code? No? You? Yeah, okay, great. I have to talk with you later. And all of those in favor of drinking a lot? Yeah? Okay, great. So we should quit this presentation and just have a beer. So, what actually is w3af? w3af, it stands for Web Application Attack and Audit Framework. When I named the tool, I wasn't really thinking a lot. Well, I don't know. Right now, I'm more into kind of marketing things, and this name is not for marketing, but it's really good for open source, and it's not going to be ever a closed source project, so it's okay. It's an open source project. It's GPL version 2. You can modify, share. You all know what GPL version 2 means. At first, it was simply a set of scripts because I was working in a company and I was doing a lot of web application penetration testing. And I had different scripts that did different things, like one script to find cross-site scripting, one script to find SQL injection, one script to brute force authentications. And at some point I said, this makes no sense, because some of the scripts were written in Python. Some of them were written in, I don't know, Perl or Bash or anything. And it made really no sense. So I started to rewrite everything into one tool, which is the result of this. And now it's a pretty serious project. We have a big number of developers. We're going to see that later. And basically, it's a vulnerability scanner. It will find the web application vulnerabilities. And it's an exploitation tool. Once the vulnerabilities are actually found, you can exploit them. Okay? You can get a shell based on those vulnerabilities. Or you can get, I don't know, information from the database. Okay? So some of the main features. It identifies almost all web application vulnerabilities that can be identified using an automated scanner. For example, business logic vulnerabilities will not be possible to discover, but cross-site scripting, SQL injection, OS commanding, almost all of those vulnerabilities can be identified. And every vulnerability is identified using a plugin. Okay, we are going to see more of this later. It's cross-platform. It's written in Python. It works in Windows, Linux, Mac, whatever. And we have a GDK and a console user interface. So if you want to, I don't know, send a scan at 3 a.m. using the console user interface through cron, you can do it. Okay? And if you want to click your way through the application, you can also do it. And it's really easy to extend. On the second session, we're going to see how to extend it. There are like 5 important things to do when you extend the framework, when you create a new plugin, and we're going to see it on the second session. And we're using tactical exploitation techniques in order to discover users, URLs, and different things about the target application. We exploit blind SQL injections, OS commanding, anything. Okay. One of the important features is that the plugins work together. They are not just different pieces of code that try to do something. They are pieces of code that are working together in order to get you more information, in order to find more URLs, in order to find more vulnerabilities. We have WML support for your cell phone web applications. We support broken HTML, which is pretty important because the web is mostly broken. And we have a smarter fuzzer. We're going to see that on session 2. Also, the start of the framework was basically a web application scanner with nothing else. Like, you put the URL, you hit start, and you waited for, I don't know, 5 hours, come back, and find the results. That was the initial idea. But now we are working also on some manual things, like a man-in-the-middle proxy, like Burp, a manual request editor, and a fuzzy request editor. These tools are from the graphical user interface, and they will help you in your manual tests. And something really important in an open source project, this is an active community. We have, at this moment, 2 developers which are helping constantly. And we had, if you look at the whole project history, we had like, I don't know, 15 or 20 developers who sent patches, who sent me new plugins, and so on. Okay, so a video is supposed to be there. It's not there. So I'm going to switch back to Linux and show you the video. Okay. I hope that you can see that. That's basically a representation of the SVN commit logs. So if at any point I was committing a file or changing a file or doing something, you're going to see one little spot around my username. That's my SVN username. And back on the bottom, you see the date. Right there, the project was just starting, and it was only myself doing crazy stuff. And at some point, we are going to see a guy named Facundo Batista approaching. Facundo Batista wrote the GTK user interface. So you see how we are all starting to work together and changing the same files or some different files. When you see two big balls of dots separating, that's a branch. Berev is Alexander Bereznoy. He's from Russia. He did some really good things with the console user interface. L. Bello is Luciano Bello, the guy that discovered the SSL bug in Debian, that worked with me in order to create the Debian package for w3af. Ulises is the guy that wrote the Windows installer. So we are going to see a lot of commits from him doing the Windows installer. And Oxdev is one guy from Russia. This guy is doing a burp proxy clone in Python and integrating it with w3af. There's one big branch that you can see. Well, the history goes on until now. So you see all of those names are guys that have SVN commit access to the w3af SVN. So it's an active community. Okay, we are working on it, and this shows the real activity of the project. Before you guys ask, this video was generated with something called Code Swarm. Yeah, like this. Code Swarm. So you can generate your own SVN commit videos with that. Okay, let's go on with the presentation. Okay, so basically w3af is divided in two different parts. We have the core and we have the plugins. The core is going to coordinate all the work, and the plugins are going to actually find the vulnerabilities. The core is going to give the plugins libraries to access HTTP. The core is going to give the plugins libraries for authentication, for cookies, for, I don't know, a lot of things. And also the core is going to call the plugins in a specified order in order to make sure that they are going to find all the URLs and vulnerabilities. And, well, the plugins find the vulnerabilities and exploit them, and they share information in order to find more vulnerabilities. One really good thing for an open source project is that the code is pretty. The code you can read from the beginning to the end and understand what's going on. That's really, really important for an open source project. Because if tomorrow I go to the street and a bus runs over me, the project is going to continue. It's not going to die with me. And that's really important for me. I don't really want to be the center of the universe, of the w3af universe. I want everybody contributing, everybody reading the code and modifying. So that's why I use design patterns and objects in all the code, and you can actually read the code. That's really important for me. We have 8 different types of plugins. We have the discovery plugins, which are going to find the URLs. Audit is going to find the vulnerabilities, and the rest we are going to see now. So the discovery plugins. Basically, they're going to create a big map of the website in order to afterwards be able to find the vulnerabilities. Something really important to have in mind is the concept of link coverage. If you are not able to find one of the links in the web application, you are not going to be able to find a vulnerability which is behind that link. So it's really, really important to actually create this beautiful map the best way possible. If you don't create this map really well, you're not going to find the vulnerabilities. And this is where we are trying to work more, because right now the discovery phase is taking a lot of time, really a lot of time, and the audit phase is working perfectly. But most users think that the whole framework is slow, mostly because these plugins are doing their job not perfectly. So I'm going to be working with this in the next weeks. Okay, so we have a web spider, which is going to simply follow links, and URL fuzzer, which is going to modify the links and the URLs actually that were found by the web spider. For example, if the web spider finds index.php, the URL fuzzer is going to try index.php.back or .zip or something like that. We have a Google spider, which is going to use Google in order to find URLs. And Picto, it's a Nicto clone in Python. So basically, the discovery plugins find something, and they send that something to the next plugin. And they do that until nothing else is found. So the web spider finds, I don't know, 5 URLs, and it's going to send it back to the URL fuzzer plugin. And that plugin is going to send back to the next plugin, and so on until nothing is found. That's the best way that I found in order to have a good link coverage. Okay. Some of the other discovery plugins that we have are Halberd, which is another open source tool which was already written in Python, and that I incorporated into the framework. Halberd basically does HTTP load balancer detection. It's going to tell you if there's a load balancer, an HTTP load balancer, between you and the target web application. Then we have HMAP, which is a signature-based fingerprint tool. AFD, active filter detection, in order to see if there is a web application firewall, if there is, I don't know, something, an IPS or something. And fingerprint WAF, it's just to try to identify which web application firewall is between us and the target web application. The problem with this is that I have plugins in the discovery family that are crawlers, which are finding URLs, and I have some others that are infrastructure, which are the ones above. They are trying to find something out the HTTP infrastructure. So that's something else that I need to break down and create 2 different types of plugins. So this is now basically this presentation is, I don't know, 5 or 10 minutes of me talking and 5 minutes of demo. So I try to prepare my demos the best. If they don't work, sorry for that, but I try to actually deliver a lot of demos because that's the only way that you guys can see what the project is about. Okay, so let's go to the demo. Okay. So we're going to see a discovery plugin demo. We're going to load the w3af user interface, the graphical user interface. And there it is. Okay. Come on. Okay, so this is basically the GTK user interface for w3af. In here we have the different profiles. These profiles are basically a configuration, which, for example, we are going to click on this one. This demo discovery profile has one target URL in here that you can see. Let's see if I can zoom in. Okay. You have one target URL. Then you have also inside the profile, you have some discovery plugins enabled. In this case, we have Web Spider and URL Fuzzer. If you click on Web Spider, you're going to see a description for the plugin and also the configuration options, which are down there. Okay. So the profile stores all of this because if we want to launch a scan more than once, then we save it to a profile and we just have it there in order to relaunch it again. So once we have everything set up, we hit start. The process starts. We see here a log of what's going on. We see a representation of this log file, and the whole thing already finished because it was a small demo. So we go to the URLs section, and we see how these two plugins were able to find these resources. They found, for example, well, we're going to see it here. It's nice. It found, for example, okay, the main host, this directory, this other directory, and it found 1.html just by following links, and then it found 1.gz using the URL fuzzer and changing the extension for 1.html. And the same thing goes with 2.html.back. That's the same idea. So for now, we have these plugins, which are discovery plugins, which discover URLs. And in this case, they discovered these URLs. Okay, we're going to go back. If at any point you have any questions, just raise your hand and it's okay. Yes?
Do you have a search that's beats NTLM?
Uh-huh.
Check that search first. Can you provide credentials and then what you bring against that?
Okay. His question was if we have a site that needs NTLM authentication, should we provide credentials and then scan it, or okay? The answer is, right now, the w3af does not support NTLM authentication. But you can use something called, there's a proxy, NTLM proxy or something like that, also written in Python. So basically, you have to run this NTLM Python proxy in your local machine. And in that proxy, you set up the credentials. And then you say, w3af, use that proxy. And everything goes with the authentication to the destination. Yeah? Yes? Yeah?
How does the plugin work in a distributed environment? Like you're saying as an example, Spider is a great example. If you have some pages that are hosted somewhere else on a different server or different environment, would you assume, as an example, if it's that specific type of server, that it's the same for every page? Or you're running or reaccessing every page differently? If one page is hosted on a Apache server with Tomcat and the other one is hosted on a Microsoft server, would you run specific analysis?
No. Good question. The thing is that, first of all, w3af is only going to follow links which are in the same domain. So in most cases, if it's the same domain, it's going to be the same server. Okay, the same, not physical server, but maybe you have 3 Apaches. Okay, then it's not really common to have 1 Apache and 2 IIS working for the same domain. And if that's the case, no, we don't support that. Yeah, but that doesn't really, that's not really important. The only important thing is what w3af sees at the HTTP level. If behind you have, I don't know, Tomcat, or if behind you have, I don't know, some kind of database, no matter what database, it's going to be the same for the HTTP layer for w3af. Okay. Any other questions? No? Okay. Great. So, we also have brute force plugins. Basically, these brute force plugins are going to brute force every login that's found. The discovery plugins are going to browse the whole site, and once the whole site is in a nice map, these plugins are going to identify if there is a formal authentication or a basic authentication or something else, and they're going to try every username and password from a small database which is included in w3af, and they're also going to try some other passwords and users which we're going to see later. There's a slight problem in here, which is if the brute force plugin actually finds the credentials, it's going to log into the web application, and then the discovery plugins are going to continue working. They're going to follow all the links in that authenticated page. But all those links will include the logout link, and that's going to log out the user again. So basically, this has no out-of-the-box solution. The brute force plugin is going to tell you that it found credentials. So there you have to stop the framework and create something using the web spiral plugin and tell the web spiral plugin not to follow the logout link, whichever it is, because maybe the logout plugin is logout.php, and sometimes it is, I don't know, in Spanish, it is salir.php. So I'm not. Something that's also interesting about w3af is that I try to do it like cross-language, or if that exists. I'm not dependent on English or German or Spanish. I try to do it in a way that it will work for every language. Regarding tactical exploitation, w3af is going to find virtual hosts in MSN search using that little trick that you use IP colon and the IP address. You search that in MSN search or Bing now, and you get all the domains hosted in one IP address. So it's going to do that, and it's going to show you the results. And you had a question? Yeah. I'm not sure if I understood your question, but yeah, no. That's a feature that we don't have right now. Most commercial scanners have something like that, like a record sequence for the login sequence, and then you check if one page you access it and it shows something if you are logged in, and on the same page if you are logged out it shows something completely different. That we don't have right now. Yeah. Any other questions? Yes?
For the files that you're looking for,
For the?
the files that you're looking on the server,
Uh-huh.
you just look for the extension, or you're also looking into the header and verifying if this is the right file size?
No. On the URL fuzzer, we just send the extension. We change the extension, and we just identify if it's a 404 or not. And then you, as a final user, are going to have to go there and identify and analyze if that's really a zip file, or if it's, I don't know, a text file renamed to zip or something else. The idea of this framework basically is to help penetration testers. It's not going to be a tool for like everybody. It's mainly for penetration testers that want to know everything about the application. And there are a lot of plugins that are going to show you information which in most cases is meaningless, but in some cases might lead to a vulnerability. So regarding to that, we are kind of verbose. We try to really, everything that we find and we think that might be helpful, we show it to you. Okay? Something else regarding tactical exploitation, we use Google in order to search for emails. This is going to allow us to, once we have those emails, we're going to use the email address, like the email name from the email address, as a user in the brute force process, which is pretty interesting. Then we have something called password profiling. The password profiling plugin is going to analyze the words that are being repeated over and over and over in a site, and using that repetition thing, it's going to identify possible passwords. If you're scanning, I don't know, a bank application, the word bank is going to be repeated a lot, and it's possible that users use the word bank as a password. So that's why that plugin is there. We also search for old versions of the application in archive.org, and we search Google, MSN Search, or Bing, and Yahoo. All of this because we want to find URLs, we want to find users, we want to find different ways of attacking this target server, target web application. So this is how a discovery and brute force plugins could work. Okay, they are working like this. This is just an example in order for you to understand. So we have these two discovery plugins enabled. We have Web Spider and we have Finger Google, and we also have one grep plugin, which is basically grep plugins are going to analyze all the responses from the server, and this password profiling is what I already told you. And we have also the brute force plugin. All of these are the enabled plugins in this run. So the Finger Google plugin is going to search for users like, I don't know, joe@sector.ca, and those users are going to then be used in the brute force process. So the Yeah.
I have a question.
Yeah.
Google has a protection for
Yeah. Every now and then we get locked out. Yeah. I haven't really found a way of going past that. If you know how, please tell me. Yeah, that sucks. At some point, you know that Google had an API that I think it was a web service, but now that web service is not more, it's not supported anymore. We have support for that web service. I'm lucky enough to still have one of those keys for that web service, and that web service is not supported anymore, but I think it's online, and we support it. So if you have one of those keys, you can request, you can search Google using that API like all the times you want. And so it's kind of strange if you have that key, but we support it. We have that library that allows you to perform requests to that web service. Any other questions? No? Great. You guys are a great audience. You ask a lot of questions. I like it. So, yeah. Okay, so the Web Spider plugin is going to follow all the links, and the password profiling plugin is going to analyze all the responses, and it's going to say, oh, okay, the word bank was repeated a lot of times here, so the password bank is most likely to be used by users. So afterwards, the brute force plugin hops in and tries to brute force different logins. In this case, it's going to use usernames from Google, like in this case, foo@target.tld. It's going to be used. It's also going to be used just foo, and some usernames like admin or test or administrator and so on that are on the default dictionary. Also, for passwords, we use something like the domain name and common words that were captured by the password profiling plugin. Great. I had one demo here for this. I'm sorry, but I didn't have the time to connect the internet and stuff. So regarding the audit plugins, we have audit plugins for SQL injection, cross-site scripting. I don't know. We try to find buffer overflows, which is kind of difficult, but possible. Response splitting, really, we try to find all the vulnerabilities that they are. Something that's pretty interesting is that in the last, I think, 6 months or so, we didn't have more than one new plugin, and that's good. Why is it that good? Because we have achieved a place. Yeah, I don't know. Excuse my English if it's not really good. We have achieved a place where we're covering most of the vulnerabilities. We don't need any new plugins in order to find new vulnerabilities, because we don't have any new vulnerabilities in our to-do list, and that's really good. We have achieved that, and I'm really proud of the whole team. So, and for each vulnerability, this is something important, and something that it takes a little bit of time to actually run these plugins. But this is because we try to identify the vulnerabilities using all the methods that we have in our hands. So we try, for example, in a SQL injection, we try error-based. Just we enter something like a single quote, and we see that error in SQL. Or we try with time delays, or we try different responses, like with and 1 = 1 and 1 = 2. We try all those different things in order to find SQL injections, in order to find I don't know, OS commanding, all the different vulnerabilities are tried using the different methods. Okay? That's really good because we don't want to miss a vulnerability, and maybe we don't have a database with all the errors, with all the SQL errors, and we don't want to miss them. That's why we try time delays. That's why we try different responses and for blind SQL injection. And also because we don't want to miss any vulnerabilities, we try something generic. We have a generic audit plugin. Yeah. Command injection, like OS commanding? Yeah, it is. It's one of the plugins that we have. Yeah. So we also have a generic audit plugin, which is going to try to break the application. Mainly, this plugin is just like a safety net in case that we don't find anything with all the other plugins. It's going to send those, that little thing that I call a syntax breaker. It's going to send that and see if an error comes back. But the good thing about this generic plugin is that it doesn't have a database of errors. It uses like a different technique in order to identify if what came back is an error or not. It has more false positives, but as I was telling you, this is a tool for guys that really want to find all the vulnerabilities and don't care much about one or two false positives. So we send this syntax breaker and we send an empty string, and with those we analyze if what we get back is an error or not. We don't work with an error database in this generic plugin. And basically how this works, we send the original request to the server, just how we found it, we send it, and we capture the response. Then, if we have something like ID equals 5 as a parameter, we send ID equal and a really long number, and we also save the response. Then we send ID equals and this syntax breaker, and with this syntax breaker, we save the response. And then we compare the three of them. And based on some logic, we say, okay, this might be an error, or this might not be an error. And that's the way how this plugin works. So basically, audit plugins find the vulnerabilities, and they save it to something called the knowledge base. This knowledge base is just an object map where you have a lot of objects lying there. And, oh, sorry. Okay, great. So all the audit plugins are going to save the vulnerabilities there in the knowledge base, and then the attack plugins or the exploits are going to read those objects from the knowledge base and exploit them. I already kind of told you what grep plugins were. Basically, they're going to analyze all the responses from the server, and they're going to tell you if something interesting is found or not. They find HTML comments, I don't know, emails, directory indexing. Something really simple is to find a blank body. So if I request something to the server and I get back in the HTTP response body, I get a blank response, that's kind of weird, right? So we report that. And the attack plugins are basically going to exploit the vulnerabilities which were found by the audit plugins. We have some of them. I'm going to go fast because let me see which slide I'm in. I'm great with time. Okay, so these attack plugins are basically exploits, and they're going to exploit the the vulnerabilities previously found. SQL Web Shell is basically a plugin that's going to write a file in the web root using SQL injection. It's going to do in MySQL, for example, it's going to do the select something into out file, and that out file goes in the web root. And well, that file that we are writing has PHP code that allows us to run commands. DAV shell is basically exploiting DAV misconfiguration, where we can, for example, use the put method in order to upload files. SQL map is a wrapper around the great tool written by Bernardo Damele. SQL map is going to exploit plain SQL injections. And, well, we have some others, but a demo is going to be much fun than me talking, right? So, any questions before we start with the demo? No? Great. Let me see. Okay. Okay. Okay, so in this case, I'm loading another profile. This profile has all the Audit plugins enabled, yeah, and it also only Audit plugins. And the targets are two. We separate targets using a comma there. So we have one target which is a script which is vulnerable to SQL injection, and we have another target which is a directory which is readable by the, you're not seeing that, right? A directory which is readable by the MySQL process. In this case, this is a demo, so we're going to work it that way. So we hit start. We see how, in here, we see how all the Audit plugins are being run, starting OS commanding, remote file inclusion, DAV, server-side includes, eval, and so on. We are analyzing all of that. At some point, this log is telling us that we have cross-site tracing, and it's also telling us that we have a blind SQL injection and some other vulnerabilities. This log is not really that friendly, so we are showing also the knowledge base where you can see all the vulnerabilities in a much nicer way. For example, we have this SQL injection, and for this SQL injection, I'm going to zoom out a little bit. And for this SQL injection, we have the description, yeah, and we have the request that was sent in order to identify the SQL injection. This is the syntax breaker that I sent, and this is the response with the whole error from MySQL. So it's pretty detailed for you guys to analyze and go through it. So the idea of this is to exploit one of the vulnerabilities. So we have here the exploits. Yeah, on your left, we have all the plugins which are exploit plugins, and on the right you have the vulnerabilities. So I'm going to simply click on one of these. When I click on SQL Web Shell, it's going to show me which vulnerabilities can be exploited by that exploit. I just do something like this. Drag and drop. It's going to be exploiting. So it's telling me that it's going to exploit, yada yada, and so on. And now we have a shell. This shell is also an object which is saved on the knowledge base. We double click on the shell, we get this, and we execute commands. Okay, just that easy. So this was nice, right? Okay. So, okay. Any questions about this? No? Sorry. Okay. Something that we also added to the framework is something called Good Samaritan. We saw that blind SQL injection, exploitation, and actually extracting the information from the database was really slow, like really slow. You know, you see the letters when you are trying to fetch from the database something like, I don't know, Andres, it's A, N, D, and so on. It makes me mad. So we were trying to speed this process up a little bit, and we found out that just by watching at the logs of the blind SQL exploitation tools, we found that we could, at some point, we could write something. And because if you see that the tool is fetching something like ADD error, you see maybe this is address, and you could complete by typing address. So that was a good idea. So we coded something called Good Samaritan. And this Good Samaritan is going to help the blind SQL injection exploitation process. And we have a demo for it. So let's go for the demo. Okay. Yeah. So something else that I haven't told you about is something called scripts. In w3af, we have the console user interface, which now we are going to be using, and scripts are basically text files with commands to run inside the console user interface. So when we pass a script like this to the console user interface, each line of this text file is going to be executed inside w3af. So we pass this, okay. So a SQL injection is being exploited. So we are seeing this process, right? We're seeing that it's saying, okay, NM, this should be name, okay. So varchar, yeah. So it told me that I contributed with char, and this was a good guess. So it's not going to actually test for all the rest of the characters. It just tests for the whole word, and if it matches, it's okay. But this is good. This can work. But we said, well, this could be better. Like, I could use something like the cell phone autocomplete feature. You know, when you start typing something, and the cell phone autocompletes the word. So we could use the same idea. And we did that. So, oh, shit. Where is this? Here it is. So in this case, we only have 5 different words in this autocomplete database. We have varchar, localhost, address, email, and country. So this autocomplete database, we can copy it into the framework, and we're going to run just the same script again. The first time I run this, the autocomplete database was empty. That's why it wasn't autocompleting anything. But right now it should. And I'm telling you it should because I did this yesterday night. So I think it's going to work. Ah, nice. So when the process sees that it's going to write var c, it says, what do I have in my database to autocomplete var c? Ah, I have varchar. So it autocompletes that. The same with address, okay? It sees addr, and it autocompletes with address. So this is going to speed up the blind SQL injection process a little bit. Okay, great. Yes?
If address isn't the correct word, say it's addresses,
It's going to,
it'll continue trying
yeah.
after?
If it's going to try address, and if it fails, it's going to continue as if nothing happened. Yeah. Any other questions? No? Okay, great. Great. So, because this tool is for guys doing penetration testing, I wanted to do something in order to basically own the server, okay? Own the server and own anything that's behind that server, okay? If that server is connected in a DMZ, I want to be able to connect to every other server or every other computer hooked up to that DMZ. So at first I was thinking about doing something like Core Impact Agent. You know, Core Impact Agent uses something called syscall proxying, and it's something kind of complex. And I was trying to do it, and it was like over my head, too much for me. And so I changed it to something different, because what I really want to do is to be able to connect through that server to other hosts in the remote network. So I did something like a VPN. So this VPN is just the name for it. It's w3af agent, and this w3af agent is going to be a process running on the owned server, which is going to connect back to me. And over that connection, that's a connect back, I'm going to send different packets, which are going to end up in different locations in the remote network. So I basically upload the agent using different techniques, like I create a server on my machine, and I use wget, I use tftp, I use echo, different techniques that allow me to upload this binary to the remote server. And then the agent connects back to me. And on the server, I run a SOX daemon. This SOX daemon is going to allow me to route anything through that server. So we had something. Okay. So how is this going to work? We have w3af, which is sending the client to the server where the web application is. Then the agent is connecting back to the agent. See, yeah, to the server. There is something in the middle there that's not in the graphic, but it's interesting. We do something called extrusion scan. An extrusion scan is basically from the server that we are trying to own, we create connections back to our box and try to see which port is open. So for example, if we are in some kind of network where we are trying to penetrate a network which is secure or something like that, we can use this extrusion scan to see if port 80 is open outbound, or if port, I don't know, 53 or whatever is allowed. So when we perform this extrusion scan, we know which port, TCP port, the reverse connection can be made. Okay, and once the reverse connection is ready, we can use, for example, an SSH client using this SOX proxy, and the information is going to be forwarded to the agent and to anywhere from there. It's something that's pretty interesting, and it's working nicely. So we have another demo. Okay. We're going to run this again. Agent. Okay. So we have, once again, we have a profile for this demo. In this case, we have an OS commanding vulnerability. This OS commanding vulnerability is just for the demo, nothing special. We're going to start. We start the process. We see how, in this case, it's showing us a lot of detail and stuff. We go to the results. We see that the OS commanding vulnerability was found. We see the details for the vulnerability. We see the request that will allow us to reproduce the vulnerability. And we see the response based on this request. So we go to the exploit section. We click on the OS commanding exploit. We drag and drop. The exploit was successful, so a shell has been created. In this shell, we can run commands. And one of the commands, which is not actually going to be sent to the remote server, it's going to be trapped and it's going to do something special, is start agent. So we do this start w3af agent. It's going to take a while, and it's going to seem like it's not working, but this is basically a GTK user interface problem that we are having. It can take something like 1 minute or so. Oh, there it is. Okay, so the agent is now running. If we go to a command, okay, so we see that there is a Python process. There's a Python process listening on port 1080, which is the agent on our side. So whatever we send to this SOX proxy that we have here in this machine is going to be sent to the other machine, and then from there to anywhere else. So this is kind of a crappy demo because everything is localhost, but we're going to try with a browser. Okay. Okay. We're going to set up in Firefox, we have to set up this SOX host. We'll set it up, close, and it's working. Okay. Using this whole trick, it's routing traffic through the owned server. So we go back to the presentation. Any questions about this? Yes?
The w3af agent
Yeah.
Gets uploaded to the target web tries to figure out a port that it can use, how is it communicating that back to the other side so it knows what port to open?
It's when it figures out what ports to use, it tries to create an outbound connection, and on the machine that you are running w3af, it's sniffing for packets. So it sniffs for, I know, port 80, 8080, 53, and it, from the owned server, it creates outbound connections to those ports. If the connection was successful, then you can use that port.
So you have to have inbound access to your...
Yeah, you in order to use this, you need to have a public IP address. Or forward packets from the public IP address to your private IP address.
Thank you.
Any other questions? No? Okay. Oh, we have 10 minutes. Okay. So, advanced exploitation. We have something also called virtual daemon, which is basically using Metasploit payloads to exploit web applications. It's something like this. So we have I'm going to explain it the right way because, yeah, it's okay. We have time. So we have something that's pretty similar to the agent. In this case, Metasploit is going to send the payload to something that we call virtual daemon. This virtual daemon is going to get the payload and create an executable file or create a portable executable, depending on if the target is Linux or if it's Windows. And once we have that executable file, we upload it, and that file is executed there, so the payload is executed there, and we can use Metasploit payloads to exploit a web application vulnerability. So we're going to upload the payload. From Metasploit, the payload is uploaded to the web application, and then we can do anything with this. So let's have a demo. Okay. We can close this, we can close this, and here. Okay, so once again, we're going to run the framework. You run it. We have one profile. This profile also exploits the OS commanding vulnerability. We have the results. Come on. It's taking some time because it's finding the OS commanding vulnerability using different techniques. One of them is time delays. So that delay that we see there is the time delay that's being introduced into the remote end in order to actually see if it's vulnerable or not. We exploit the OS commanding once again, and in this case we execute start virtual daemon. Okay, now we go to Metasploit framework, and we're going to execute one of the modules there in Metasploit. That module is a module specially designed for w3af, which I wrote, which is simple. It's going to send the payload to a port and do some interaction. So we have exploits, multi. This is the one. Execute. It's a Linux machine. Forward. We just want to do bend. Okay, so we're going to be exploiting this host, and this is a port that's going to be used for listening to connections. I don't see. We hit forward. Now the communication between w3af and Metasploit is here. We see that the extrusion scan was performed. We see that the portable executable ELF was transferred to the host that we now own. And it's going to take 42 seconds to run, because what I do in this case is I run the payload using cron. I don't actually run it using the OS commanding vulnerability directly, because in some cases you get timeouts, and that's not really good. So now we have this shell in Metasploit, which we got using all this idea from virtual daemons and stuff. In the future, if the guys from Metasploit have something like, I don't know, Metasploit for Linux, we can use it. We can also exploit, using this virtual daemon, we can exploit Windows machines. It's pretty good. Once you have some way of executing commands on the remote end, you can use Metasploit in order to keep on owning the machine. Okay. That was a demo. We have other plugins, and in the future we are trying to perform something like that I call live scan. Live scan is going to be a proxy which you are going to use, and while you're using it, the proxy is going to send requests to the remote host and find vulnerabilities. You don't have to do anything. You just browse the whole application, and the proxy is going to find the vulnerabilities and exploit them. And at some point, you're going to go back to that proxy window, and you're going to see that you have 3 shells in some random servers that you were browsing during the day. Okay, that's one idea that I'm going to be working on. We are going to enhance the management reporting, because right now the reporting that this tool gives you is mostly technical and doesn't show any nice graphs and stuff. So management doesn't like to read things without graphs. And okay, we're going to enhance the man-in-the-middle proxy. This man-in-the-middle proxy that we have now is not really good. We are working on it. We are trying to create a burp proxy clone in Python. I'm going to be releasing 1.0, version 1.0 in a few days, I think, I hope. And for the conclusions, w3af, it's growing. Okay, it's a project that more users are using, and it has a huge potential. We have been working on this for 3 years. I've been working for 3 years, some guys 1 year, some guys 6 months. It has a lot of potential. I think that in the future we are going to be competing directly with the commercial scanners. A lot of bugs were fixed, really, a lot of them were fixed. And now the project is way more stable. Like, if you run the version that we were working on 1 year ago, it was going to crash every time. And now, if you run it, it's not going to crash, like almost never, or it shouldn't. The last year was mostly bug fixing, so it's way more stable now. We're going to work on performance, because as I was telling you, the discovery phase is kind of slow. And if you guys want to contribute with plugins, they are always welcome. But what I really want is you guys to use it, you guys to contribute, you guys to report bugs, tell me this you could do better, this you could change, That's what I really want to. So if you want to contribute, this is a project website. We have different mailing lists. We have an IRC channel. If any of you are teaching web application security classes, please include this tool in your classes in order to promote it. And another way to contribute is to attend one of my w3af trainings. I'm going to be giving a 2-day training in New York in December, this December. So if you want to go, you are free to do it. Anybody like remotely thinking about contributing? Raise your hands. One guy there, one guy there. Okay. So, white or black? Black. Black? Okay. Okay. Great. So, any other questions? No? Yes?
When running on a Linux machine, does it need to be compiled from source, or are there already some packages that can be Bluetooth or Debian repositories for it?
In Debian, you just use apt-get install w3af, and it will work. That's all you need to know, at least in Debian.
You know if you have packages in Think for Mac OS X?
No, I don't know. I don't know. There might be, but I don't know. Yes?
The question earlier about internet support, and your answer was using proxy. Is that something that can include in the future?
Yes, yes. The problem was that 1 year ago, we didn't have something called an URL lib handler for NTLM. So that was not available 1 year ago. But right now, a guy wrote a handler for NTLM, so we can include it into the framework easily, and we are going to. Yes. Other questions? Yes? Yes, it's able to scan web services. There is one problem there, because the web service library that we use, it's called SOAPy. And SOAPy only supports one of 2 types of web service definition languages. There are 2 types of WSDL, and they only support one of those. If you're lucky enough to be scanning the one that's supported, it's going to work. If not, I don't know. It's not, of course. Questions? Any more questions? No? Okay. So, I had some suggested questions just in case that you guys were shy or something like that, but you were not shy at all. So, all of this goes like, has no sense. The only one is, I would like to visit Argentina, but I don't know where to go. You should go to Buenos Aires, you should go to Patagonia, and you should go to Iguazu, which is kind of Niagara Falls, but in Argentina. So, okay. After a break, we're going to have a comparison between these scanners and also Sensic. We're going to have the features that are going to allow you to perform manual analysis on web applications. And we're going to write a plugin from scratch. We're going to see some things about the Moth project. And all of that is going to be on the next session on this same location. Okay. Thank you, and see you later.